Hey, in this video, I'm going to briefly introduce you to how we can represent negative numbers in binary. So I'm going to teach you something about 2's complement. Okay, and 2's complement is a way that we can represent positive and negative numbers in binary. All right. Now, what I want you to consider today is we're going to use 1 byte. Okay, so we're going to do 2's complement and we're going to use 1 byte. Okay, now 2's complement and 1 byte will allow us to represent all the numbers from minus 128 to 127. Okay, now this is one thing we've talked about. Okay, a byte can represent lots and lots of different things. Okay, if we're just doing normal binary, okay, if it doesn't say we're doing 2's complement, then a byte represents all the numbers from 0 to 255. Okay, if we're doing 2's complement, then a byte represents all the numbers from minus 128 to 127. Okay, now what I want to do is just very quickly explain how that works. Okay, now the easiest way to do it is to draw a number line. Now I know you probably haven't done number lines since primary school, but I want you to give it a go anyway. Alright, so we're going to draw a number line. I've just changed my colour because I got a bit bored of that red. Okay, so here's my number line. Okay, and I'm going to put the positive numbers here. Now I need to leave plenty of space because they're going to be a byte long, so that's going to be pretty big. There you go. Alright, so there's my number line. So this number here is 0. Obviously, this is 1, this is 2, and this is 3. Okay, so if we're going to write 0 in binary, and we're using 1 byte, it's going to be 0, 0, 0, 0, 0, 0, 0, 0. There you go. Nice and simple. Okay, so that's 0 in binary using a byte. Again, we're going to do 1, so that'd be 0, 0, 0, 0, 0, 0, 0, 1. Okay, 2 is going to become 0, 0, 0, 0, 0, 0, 1, 0, and 3 becomes, and of course this should all be revision for you, alright, and if it's not, then please check out one of my other videos on how binary works. Okay, so on our timeline, I've done the positive numbers from 0. Okay, now what we're going to do on our timeline is we're now going to go backwards. Okay, so now we've got minus 1, minus 2, and we might just fit in minus 3 if we make it nice and small. Okay, so the reason why I put it on a timeline is because what I wanted to do is think about what was the, if you were going, so when we go forwards, this is what we get, this is the pattern when we go forwards. Okay, what would the pattern be if we were going backwards? Okay, so what would the number be before 0? Okay, well, basically what you need to do is it becomes 1, 1, 1, 1, 1, 1, 1, 1. Okay, and that is minus 1 in binary. Okay, because that's the number that you'd get before you go to all zeros. Okay, if you added 1 to that, you would get all zeros. Okay, so that's the next one up. All right, if you take 1 off that, what do you get? Okay, so again, we're going to take 1 off this again, and what would we get? We get 1, 1, 1, 1. Okay, 1, 1. 1, 0. Okay, now make sure I don't make any mistakes. Alright, writing lots of 1s and 0s is the reason why we have hexadecimal, and which again is in another video. And then minus 3, so what's the 1 before that? So we're always taking 1 off. Okay, so minus 3 would become 1, 1, 1, 1, 1, 1, 0, 1. Okay, because that's the 1 before minus 2. Okay, so that's how we represent negative numbers. Okay, now I can see you thinking to yourself, Mr. Molson, that's great. Okay, you've explained to me how negative numbers are represented in 2's complement. Okay, but I can't draw a really large timeline to work out what minus 57 is, or minus 102. Okay, so I'm going to show you a really quick and fast way, all right, to convert from a positive number into its negative equivalent. Okay, so what we're going to do is well, let's do minus 3. Okay, so what you do is you start by writing out the number that is the positive version of the number. Okay, so 3 would be 0, 0, 0, 0. I'll change colours again, hope you don't mind. Okay, and so there's 3. Okay, so this is a 2-step process. All right, so step number 1 is to invert the 1s and 0s. Okay, now invert the 1s and 0s just means that all of those 1s and 0s, if it's a 1, it's going to become a 0, and if it's a 0, it's going to become a 1. So there we go, I'm going to put 0, 0, 1, 1, 1, 1, 1, 1. Okay, so that's step number 2. Step number 1, sorry. Step number 2 is to add 1. Okay, so I'm now going to add 1 to what I've got here. So I'm going to go plus, there we go, 0, 0, 0, 1. Alright, now we can do this again. This is a little bit of revision, but if you're not sure how to do binary arithmetic, then just check again. There's a video. So we've got, sorry about that, let me bring that back down, sorry. Alright, so we've got 0 plus 1 is 1. We've got 0 and 0 is 0. Alright, and then we just follow the rest on. So we've got 1 and 0 is 1, 1 and 0 is 1, 1 and 0 is 1, 1 and 0, 1, 1, 1. Okay, so now we've gone, very quickly using those 2 steps, we've gone from 3 plus 3 all the way to minus 3. Okay, and we can just have another go. I'll just show you again. So let's do, we said 56 earlier, didn't we? So let's do 56 in binary. Okay, so we'll do it in positive first and then we'll do it to negative. Okay, so if we're going to do 56, we're going to say we don't need a 128 to make 56. We don't need a 64. Okay, we do need a 32 to make 56. We do need a 16, which makes 48. We need an 8. Okay, we don't need a 4, we don't need a 2, we don't need a 1. Okay, so there's 56. This is the positive version of 56. This is plus 56. Okay, and what we're going to do is we're going to follow our steps. So step number 1, which is here, says to invert the 1s to 0s and 0s to 1s. So we're just going to swap those all around. Like so. Okay, and then step number 2 is to add 1. So we're then just going to add. Alright, and you do want to be careful, making sure you get everything lined up with your binary, because it just helps. Okay, and so we've got 1 and 1, which gives us a 0, and we're going to carry a 1. We've got 1 and 1, which gives us a 0, and a carry. We've got 1 and 1, which gives us a 0. And then we've got that carry down there. So we've got 0, 0, which gives us a 1. 0, 0, 0, 0, 1 and 0, 1 and 0. Alright, and that is, so now we've got, so this was plus 56, now this is minus 56. Okay, so in this video, I've hopefully briefly explained to you how to use 2's complement to represent negative numbers in binary. Thanks for watching.